Hey guys, I'm going to show you how to do this very complicated looking differentiation question. So I highly recommend you give this a go first. Now, when you're doing some question like this, it's always useful to identify the constants. So in this case, you have like this 2 and you have this 5, right? So since it's just a constant, we can just pull that out the front. Okay? And we can just try to focus on, so we're differentiating in terms of x, so we can just focus on this bit here. Okay, so I'm going to say dx. Now, one way to, maybe I'll just write this out. Cube root 1 minus x power 4 squared. So, oops. So when you're trying to differentiate these, remember how, basically since our whole differentiating journey stemmed from here, right? As long as we know the power of a particular polynomial, then we can always differentiate it. The thing with this one is it's got some power, but it's not very clear what it's going to be, okay? Because there's a lot of square roots, or actually in this case, it's a cube root. Okay, so we're going to try to change this from surd form to index form. Okay, so 2 over 5 multiplied by d on dx. And this one, I'm just going to take my time here and say 1 over to the power of 2 on 3. Okay, so from here it's really just index rules. So 2 on 5, d on dx, and then we can bring it up to the numerator and say 1 minus x power 4, like this. And then from here we can just apply our chain rule and differentiate. So we can bring the minus 2 on 3, subtract 1 off that, so we should get minus 5 on 3. And our chain rule is the derivative of the inside, which is just negative 4x cubed. Okay, so let's just clean this up. We have a negative and then a negative there. So that will just become positive. And then we have, so 16 over 15. And let's say x to the power of 3 on top. 5 on 3 bottom, like that. And the last thing is, let's just change this back to surd form, since the question gave it to us in surd form. So hopefully you remember from your index laws. This will be power 5 on 3. Okay, and that's the answer. So that's how you differentiate this really difficult looking question. Okay, so hopefully that was helpful, and I'll catch you guys in the next one. Laters.